Okay, so now we're going to level up a little bit and do a slightly more challenging problem. Example number 2. Y equals 2 parentheses 3x minus 1 quantity squared minus 20 as the outside k value. When we have a problem like this, noticing that there's an a on the outside, an a on the inside, an h on the inside, and a k on the inside. Again, going back to what we know about our vertex form, which is written like this, always, with that a on the outside, h and k vertex form, what we can do with this is we can use the exact same steps, except that in this case there's going to be a few more steps added, obviously. First thing we're going to do is still use that zero product property, use the ZPP still, and set the equation equal to 0 instead of equal to y. Now if there were something over here with the y, we would need to, like a constant, a number, we would need to move it over as well. But for today, we're just going to go ahead and start with a y equals equation, use the ZPP, and substitute in a 0. So now we have 0 equals 2 parentheses 3x minus 1 quantity squared minus 20. And now we're going to do the exact same steps that we did previously, except there's a few more, again, a few more added steps. We're going to start by eliminating the k value. So we're going to start by eliminate the k, which is this negative 20. The inverse of negative 20 is positive 20, so we add 20 to both sides. Do our little demarcation of the equal sign. And now we have the equation 20 equals 2 times 3x minus 1 quantity squared. Okay? Next step is we're going to eliminate the outside a value. Eliminate the outside a value. In this case, that a value on the outside of the parentheses is the number 2. So we're going to divide both sides of the equation by 2. I know that some of you have gotten into a very bad habit of just putting one big fraction bar and then putting the number 2, and that's a really terrible idea. I have seen it so many times people do that, just being slightly lazy, and it makes an error for the whole problem. You forget to actually do the division, and then everything else after that is wrong. So I really encourage you to just take the extra 1.2 seconds and divide by 2 to both sides. Now we have the simplified equation, because 20 divided by 2 is 10, equals, parentheses, 3x minus 1 quantity squared. Okay. Our next task is going to be to eliminate the power of 2, just like last time. Eliminate the power of 2. Again, the inverse operation of squaring something is square rooting something. And when we square root both sides of an equation, we must remember to put a plus or minus sign on the front of the numerical side. So we put a plus or minus square root of 10 equals the square root of 3x minus 1 quantity squared. Now we need to go ahead and simplify the right side of our equation. The square root of a squared value is just that value, so now we have 3x minus 1 equal to plus or minus the square root of 10. Now we can't simplify the square root of 10, so we're just going to keep it as it is. Next we're going to eliminate the constant. The constant is the number that is not attached to the variable. It's the number all by itself. In this case it's negative 1. We're going to add 1 to both sides. I'm not going to add it to the radical inside the radical. I'm going to add it to the outside of the radical. And again, I would encourage you to do the same. You're setting yourself up for a lot more success this way. Now I have the number positive 1 plus or minus the square root of 10 equals positive 3x. My last step is going to be to divide by the coefficient, or eliminate the coefficient. The coefficient is the number that is multiplying the variable. Eliminate the coefficient. And yes, you should definitely have all the steps listed mostly for future reference, but also maybe on the test when it asks you to explain all the steps. You already have them for your viewing pleasure. So the opposite of multiplying by 3 for that coefficient of x is dividing by 3. So we're going to divide by 3 to both sides of the equation. 3 divided by 3 is 1. And therefore we have a final answer of x equals 1 plus or minus the square root of 10, all divided by 3. That's our final root, or roots. You'll notice the plus or minus sign, which means that we have a positive version of the answer and a negative version of that value. So we already know that there are 2 roots, but the question is, are they 2 real roots or 2 imaginary roots? Well, we look at this number 10 on the inside. The number 10 is positive. Therefore, it's a real root. The only way to have imaginary roots is if this number inside of the radical was a negative. So we have 2 real roots. Now, I'm not saying that we actually know what these numbers are. Like, this is our final answer unless we use a calculator to help us compute the decimal approximation so that we would be able to graph it. However, all I'm asking is, what does this tell us about the graph of the parabola? This tells us that the parabola will cross the x-axis twice. It really crosses the x-axis twice. That's why it's 2 real roots. And you can see how this question is slightly more rigorous. It's a little bit harder, more challenging than the beginning one, but you can see that there's still the basic steps that are followed in order to accomplish the same goal of asking how many times does this parabola cross over the x-axis?